and it was a mix of excitement and curiosity. Over the past few months, I've had the privilege of watching that initial uncertainty transform into confidence, skill, and genuine contribution to our team. Internships are described as a bridge between classroom and the workplace, but in reality, at Esri Sun Africa, they are much more than that. They are a testing ground for ideas, a space to learn, and a chance to discover not just what you can do, but who you can become in a professional setting. Our interns didn't just complete tasks, they embraced challenges. They asked thoughtful questions, brought fresh perspectives, and reminded us that innovation often comes from those who are willing to see things differently. As a supervisor, I've been inspired by your willingness to learn, your resilience when things didn't go as planned, and your ability to turn feedback into action. You've really grown not only in technical skills, but also in professionalism, communication, and by and large at problem solving. So as we move forward, remember that the qualities that you've shown here, curiosity, persistence, and collaboration will serve you well in any path that you choose. Keep asking questions, keep challenging yourself, and never underestimate the value of relationships that you've built along the way. On behalf of the entire team at Esri Eastern Africa, I want to thank you for your hard work, your energy, and your fresh ideas. You've left a mark here, and I have no doubt that you'll continue to make an impact wherever you go. Congratulations on completing this chapter, and here's to many chapters yet to come. And with that, I'd like to invite the team lead, Linus Anari, to give a few remarks before we start on our presentations. Linus?
All right. We are having a challenge with my audio, but I hope that you can all hear me. I hope that you can all hear me. All right. Let me just first start by saying that I believe myself that I speak for the greater group of interns across Eastern Africa, from Uganda, from Tanzania, all the way to Kenya. Well, when I said that, we thought we knew GIS before we came, and now we've had to relearn the entire GIS all from scratch. And I must say, it has been a really, really interesting and a lovely experience altogether. I'm gonna acknowledge there are so many brilliant minds in here, Esri Eastern Africa, and also Esri at large. And that is one of the things that I feel like that we're really, really humbled and deeply honored to have had the privilege of interacting with them. And also, I'd like also to thank the entire Esri in general for having provided such an enriching environment for us to open our minds to the immense potential of geospatial technology. And most, most importantly, I'd also like to thank Esri for offering that bottomless coffee machine that has always kept us running through every single day, and yeah, through the project. So yeah, thank you so much, Joyce, as well, for your patience and support with us. And over back.
Yeah. Am I audible? Hello. Kindly confirm if I'm audible.
Yes, Clinton, we can hear you.
Okay, thank you. Once again, confirm if you can actually see my screen. If you can see it, maybe a thumbs up, or you can just say something. Oh, thank you so much. Thank you so much. So, yeah, thank you. So, good morning, everyone. Uh, my name is Clinton Omondi, and it's an honor to present to you today. And maybe before I begin, allow me to introduce myself briefly so that you can actually know who is presenting. So I'm a geospatial engineer. I also do data science as well as uh, I'm also a full stack web developer. And my passion lies in integrating AI together with the GIS to create, practical and impactful solutions that actually addresses real world problems. Also, I am experienced in working with the front-end frameworks like React and also building the back-end servers like using the Django and Py and Node. Uh, Beyond that, I am also deeply committed to mental health awareness and community well-being. I also mentor students in Python, data analysis, and geospatial programming, helping them build the real-world technical solutions. So today I'll be presenting the culmination of the internship work here at ESRI, Eastern Africa, and the project is about the Nairobi Emergency Medical Services Coordination System. Yeah, but before I dive into the project, I must express my heartfelt gratitude to the people and the organization that made this possible. And first and foremost, I want to thank ESRI Eastern Africa for this opportunity. Yeah, my experience here has been nothing. It has been nothing short of transformative. From day one, I've been welcomed into a community of professionals who, they're not just experts in GIS technology, but they're also passionate about using this technology to solve, Africa's challenges. The kind of solutions I've seen they come up with are just great. But specifically, I want to thank Joyce, who was in charge of interns and ensured everything ran smoothly from the beginning. And Joyce, if you are actually listening, your organizational support and your continuous check-ins kept us all in track, all on track, all the interns. And Joyce also happened to be my project supervisor. And thank you so much for being hard on me, especially in the beginning. Yeah, you pushed me to ensure the project actually works and not just, something that looks good on paper. Yeah, your thoughts, your guidance, and your availability actually made this project better at every stage. And from helping me get the licensing issues sorted to your continuous feedback, yeah, they've been instrumental. I'm also deeply grateful to Dennis Mwangi and Jackson Mbugua, who supported me in familiarizing myself with Esri tools. Yeah, you answered countless questions. You showed me how to do things the right way, and your technical knowledge was so very invaluable. Yeah, to Kevin Kamau, yeah, you're my support system during the early stage, the early project formulation, and your thoughts and insights also helped me shape the foundation of what you're about to see today. And to Victor and Wens, that's Wens Close, thank you for helping me narrow down the problem statement, and Wens especially for helping me focus on what really matters. Yeah, and to the entire Esri team, Esri Standard African team, thank you for your warmth and for providing the environment and tools I needed. And honestly, for the daily continuous tea, every single day, those tea breaks, they were more than just refreshments. And yeah, they were, moments of community and bonding and coming up with some good ideas. And finally, to my fellow interns, thank you for the community we shared together. We also learned together and grew together. So thank you so much for that. Yeah, so let me just dive to the project. Now, let me show you what I have built. And what you're about to see is fully functional GIS-based platform designed to solve one of the Nairobi's most critical problems. That is the emergency response delays that cost lives. And as you can see up here, it is titled GIS-based ambulance dispatch optimization system for Nairobi. And let me just start with a reality that might shock you. Right now, if someone in Nairobi has a medical emergency, the average ambulance response time is actually about 35 minutes. And in many cases, that's simply too late. That's too late. And what is actually surprising is that in Nairobi, we have about 150 to 200 ambulances. So the problem is not about the shortage of the vehicles. The real problem here is the chaos and the poor planning. These ambulances, they operate with no central coordination, and dispatchers have no visibility of where ambulances are. Also, the citizens or the users can't request, help digitally, and multiple private operators, those are the private hospitals and even the public hospitals, they were completely independent. And what is the result of all this? It's the preventable deaths that we could have prevented, happens every single day. So I asked myself a simple question. What if we could coordinate these existing ambulances intelligently so that we could help save lives? And that is what this system is actually doing. It is a cloud-based GIS platform connecting three groups, that is the citizens who need help. We have the dispatchers who coordinates the response, and the paramedics who actually save lives. And that is what it is about. And the best part of it is that we don't need to buy a single new ambulance. We are simply organizing what is already existing. So that, in short, is my problem statement and how I thought about it. And so my main objective was actually to develop a GIS-based system that optimizes ambulance dispatch operations in Nairobi County, demonstrating how spatial intelligence can reduce emergency responses and ultimately save lives. And these are my specific objectives. That is network analyst optimization and network analysis and optimization, where I came up with an algorithm that help identify fastest routes from ambulances to incidents and also from incidents to the appropriate hospitals. Uh, Also coverage gap identification. I did real-time simulation as well as predictive analytics. And finally, I also came up with policy recommendations, which can actually help the Nairobi County to formulate these idea. And these are my deliverables or what is expected of me, and they're already here. The automated routing system, real-time dashboard, as well as the comprehensive documentation. Uh, so to build this scientifically, I started with the multi-criteria GIS analysis in ArcGIS Pro. And here, just let me show you my screen so that you can actually see what I did. Just a minute. Uh, yeah. Yeah, so this is my screen. This is the analysis I did, where I used the weighted overlay analysis with four criteria. The first one was the weight on population density, where I used the 40% weight and also the 30% proximity to major roads in Nairobi County, and proximity to hospitals, I gave it 20%, and also avoiding accidents in black spots, I gave it 10%. And this produced a suitability map, which you can see here, showing the best locations for dispatch centers across Nairobi. The darker areas, or let me say the ones which are in blue, in green, represent higher suitability. And you can see the stars. The stars, they represent the dispatch centers. And based on the analysis I carried out, I placed 12 dispatch centers strategically across the Nairobi County. And these are not just random locations. The stars you can see here, each center is positioned to maximize, the coverage in areas like the CBD, Westlands, Kasarani, Embakasi, and and Kibra. I then allocated 70 ambulance across these centers based on population density. The CBD, for example, got 8 ambulances, Kasarani got 8, Eastlands got 8, and smaller centers also got 4 to 6 ambulances each. And actually, this meets the World Health Organization Africa standard for the ambulance to population ratio. Next, after that, I also calculated the 15-minute service area for for each center. That's a 5 kilometer radius, assuming 20 kilometers per hour average speed, which is actually realistic for Nairobi traffic, as you can imagine. So this was the buffer, and that means areas around these actually uh, they have 15-minute service areas. So the result of this gave about 68% area coverage, and that is 478 square kilometers out of 708 total. And now maybe you might ask yourself, how about the other 32%? And if you look keenly at the map of Nairobi, the uncovered areas are mostly the Nairobi National Park, also the low suburbs and the agricultural land in Nairobi. And when we look at the population coverage, we are actually reaching about 90% of Nairobi residents. And this is something strategic, and it focuses the resources where people actually need them. Now, to show you my system architecture, my system architecture. Mhm. Yeah, yeah. So this is my system architecture, and at the foundation, you see at the foundation here, we have 6 datasets. Uh, we have 12 dispatch centers. We have the 70 ambulances. We have the emergency requests, and here it's in the survey 1 to 3. We have the hospitals and also the coverage zones as well as the road segments. This data is being managed by the ArcGIS Online, which provide feature services and the real-time updates, and also help us in data collection using the survey 1, 2, 3. On top of that, I built three web applications using the ArcGIS Maps SDK and the React. That is a citizen request app, the dispatch console, the paramedic field app, and this is complete, cloud-based, and it's also end-to-end, as we'll see in a few. And right now, I want to show you the applications I have built, which are fully functional web apps working right now. I developed them using, again, the React and for front end, and in the back end I used the data and the connections are basically in the ArcGIS Online as feature layers. And let me walk you through each app. So let's start with the Citizen app. I hope you can see my screen. So um, in the Citizen app, imagine you are witnessing an accident in Nairobi, for example, and you open your phone and immediately you see the screen that report an emergency, and then you tap or you click the request, the report emergency now, and in the report it will show you a form, and the form is actually connected to the survey 1, 2, 3. So whatever we are going to fill here it's actually embedded on survey 1, 2, 3. So form asks you for the type of emergency, assume it's fire, and then again it asks you to fill your phone number. Let me say, for example, Clinton, uh, and yeah, Clinton, and then you put your number. For example, this the people needing help, and maybe the person is not responding, the type of emergency, person is not responding, and then you continue. And what's powerful is that the GPS coordinates are captured automatically, so it will capture your location where you are. Therefore, you don't need to describe where you are. The system automatically knows, and then you can review and confirm that. So after confirming and sending your request, you get a response that dispatchers are actually reviewing your emergency and they will respond shortly. And then if you come here, you'll see the the in the dispatch console, then this is the nerve center of the entire system. When a dispatcher logs in, they see everything in the real time on one screen. It's a live map showing all the 70 ambulances I was talking about across Nairobi, and they are color coded. For example, the green, if you look at the legend, the green, the green are for the available ambulances, and for the blue is, if ambulance has been dispatched. And also, if you look at this one, these are the hospitals around, and whether the hospital is closed, like the gray one shows whether the hospital has been closed or it's open. The open ones are the blue, and the closed ones are the gray ones. So when a request comes in, the dispatcher, okay, sorry, at the top here, you can see real-time statistics. How many ambulances are available? For example, available are 67. How many emergency requests are pending? Like now, right now we have 6, and the total active emergency are there as well. So when a request comes in, the dispatcher clicks that request. The one we've just sent right now is this one. So the dispatcher clicks that one, and the system shows the nearby available units or ambulances, and it recommends the best one. And therefore, a dispatcher can select, or if you wait for longer than 30 seconds, it will automatically select the best one. So they select, and then it will the assignment is sent instantly. And then if you come here in the ambulance fleet, you can see that actually there's an ambulance under the dispatched. There's one that has been dispatched right now. And let me say it is this one. This one. I think it's this one. And then we move on. So before this system, the problem is that, the dispatchers had no visibility. They managed ambulances by phone calls, and basically guesswork. But now they have a unified operation center with complete situational awareness, and therefore they know actually what is happening. Meanwhile, in the ambulance, the paramedic has the paramedic, filled up this one. And when assigned to an emergency, their phone immediately shows the assignment. So, but you have to log in first as a paramedic. So when they sign in, they'll see that actually there is an incoming request and they need to start a journey. So they'll just have to accept that, and mm, the vehicle will start moving from, the dispatch center to the incident, the point of incident. And as you can see, the red one is the emergency point, and the vehicle is moving. But now on the side of the citizen app, you'll see that for them, they also see an ambulance coming. I don't know if I chose the right this paramedic, but they should also see the the vehicle coming. I think I chose the wrong one. Now, as it moves with time, every status is updated, and so the system calculates the response times with, zero manual data entry. You don't do anything. And once the paramedic picks the patient, they need to know which hospital is the best. And, most systems like the one we have nowadays just says that, go to the nearest hospital. But what if that hospital is full? Or what if they don't have the right specialists? Or what if, the wait time is longer, for example, by 45 minutes? So this system is smarter than that. And I built a system ranking algorithm. You see, right now, the paramedic has arrived, and all they have to do is, arrive at the scene, and then they start transporting them. But now, it will ask them, it will show them the best hospitals. For example, here we have Nairobi West Hospital. So they will select that, and then they will start. They will transport, the 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 sick to that hospital. The green one is the hospital, and the red one is still the emergency point, and the ambulance is moving across, as you can see. And mm, what happens is that I built a hospital ranking algorithm that evaluates all the hospitals using 6 weighted factors. The 30% on distance, 24% on specialization match, 20% on bed availability, 15% on ICU capacity, 10% on wait time, and plus bonus points, for surgery, blood bank, and also the ambulance bay facilities. And let me give you an example. Assume road accident victim is in Westlands. Hospital A is 2 kilometers away but has no trauma unit. Hospital B has trauma but is 85% full with maybe 45 minutes wait. It will score low. Hospital C is 4 kilometers away, has trauma and surgery, but is 40% full and has a 10 minutes wait time. It scores best, and therefore the system recommends Hospital C, even though it's not the closest, because the patient will get faster and better care. And basically that is how it works. So what's the impact of all of this? Number one, the response time reduces from 35 minutes to 15 minutes, and that's actually 57% improvement. Also, like I said, the coverage now is from chaos to 68% area coverage, which is about 90% population coverage. And the cost, zero new ambulance purchased. We're just, coordinating the existing resources. And therefore, eventually lives will be saved, and the country will be happy and people will be happy. And this basically is what the project was. This is basically the entire process and the entire system I built to show you that we can build something like this to help save lives in Kenya and in Nairobi as a whole. So once again, I want to thank you for making this possible and for listening to me. I will invite the next presenter, that is Bridget Mwema, to present with us. Yeah, thank you.
Someone can confirm. Go ahead, Bridget.
Am I audible right now?
Yes.
Okay, thank you so much. All right, let me proceed. I'm sorry for that. I'm having an issue with my audio. So I'll be presenting my project entitled Flood Hazard Mapping Analysis in Tana River County. This is a GIS-based approach to flood preparedness and response. Before I continue, allow me to briefly introduce myself. My name is Bridget Njoki, a graduate from the Technical University of Kenya in Nairobi, having been awarded a Bachelor of Applied Sciences in Geoinformatics. So my coursework for the past 5 years has focused on GIS, remote sensing, cartography, and survey. I am passionate about environmental conservation and disaster management, and I do try to integrate GIS to solve real-world challenges related to this field. I have served as an intern at Esri for the past 3 months, and my experience has been very educative in that I have had the chance to learn, interact, and use ArcGIS products such as ArcPro, especially in tackling this project. Allow me to express my gratitude to my supervisors, that is Joyce and Latima, for supporting me in this journey. It hasn't been easy. I've experienced some challenges, but I do thank God that I've been able to reach this point. I also thank Dennis Mwangi, Dennis Kyogora, Jackson for supporting me also, and my fellow interns. Thank you so much. So a brief introduction of my project. This project has focused on flood hazard analysis in Tana River County. I have used GIS to identify flood hazard zones and infrastructure such as schools, settlements, roads, and health facilities. So the aim is to support better planning and risk management. The project has been directed to disaster risk reduction in management, specifically focusing on preparedness and response. A brief background: Tana River County experiences frequent flood events. Record actually shows that it experiences floods twice every year. That is March through April to May, and October through November to December. This is mainly caused by the overflow of River Tana after heavy rains, which ends up affecting settlements, infrastructure, livelihoods, and people's property. For my problem statement, flooding continues to cause major damage in the county. Most settlements and facilities are actually located in high-risk areas, so there is a lack of clear spatial data to support planning and response. So this project aims to bridge this gap. For my main goal, I basically focused on mapping and analyzing flood hazard in Tana River County in order to support flood preparedness, response, risk management, and decision-making. Throughout my project, I have been guided by the specific objectives to identify different flood zones, to identify infrastructure within the different flood zones, to generate high flood prone area map, to identify infrastructure within the highly flood prone areas, to generate a settlement suitability map, to identify infrastructure within the settlement suitable areas, and to design an interactive dashboard to visualize my results. On my screen is the solution architecture which guided me throughout my project. For my data sources, I used elevation, that is DEM, infrastructure such as the settlements, schools, health facilities, and roads. Number 3, river Tana and hydrology data. Administrative boundaries, that is the Tana River County boundary and the wards. I also focused on past flood data. For data processing, I used ArcGIS Pro for this specific task. That is data collection, data cleaning, coordinate system reprojection, data clipping, and attribute preparation. The next point was spatial analysis. That is flood hazard mapping, where I generated a flood hazard map, including highly prone areas map and the infrastructure per the zones. There's also the settlement suitability map. This is just showing areas that are suitable for settlement, as well as the infrastructure in this particular map. For my outputs, I have the flood hazard map showing the high prone areas, moderate prone areas, and low prone areas. I also have the settlement suitability map showing the areas that are highly suitable for settlement. For my visualization, I used ArcGIS Dashboard and ArcGIS Experience Builder. Just to show this map, that is the flood hazard map, high flood prone areas map, settlement suitability map, and Tana River County flood overview. So this is my ArcGIS Pro. This is what I've done. So basically, I used fuzzy logic and Euclidean distance to develop this flood hazard map by integrating multiple flood-related factors. So Euclidean distance was first applied to the river network to determine how close each area is to the river, with closer areas being more prone to flooding. Key variables such as slope, elevation, and distance to the river were then standardized using fuzzy logic into a common scale where higher values indicate higher flood susceptibility. Each factor was assigned a fuzzy membership function based on its influence on flooding. So finally, all the fuzzy layers were combined using fuzzy overlay to produce a continuous flood hazard map, highlighting areas from low to high flood risk and supporting settlement suitability analysis. So just like I mentioned, I have used a couple of infrastructure or other facilities, that is the roads, the settlements, the schools, and the health facilities. This layer is basically showing my flood map, where the red indicates areas that are highly prone to flood, while the green is indicating areas that are lowly prone to floods. So afterwards, I extracted the high prone areas, which is depicted by the red color. And as you can see, it's just surrounding the river. And you notice that most infrastructure are actually in these areas. So I have done a couple of analyses where I've got the counts for settlements within flood-prone areas, counts for schools within flood-prone areas, as well as health facilities and roads. Next up, I extracted the settlement suitability areas. So as you can see, The green is showing areas that are lowly prone to floods. But the area is also used for other services such as national reserves. You find that there are areas with scrubs and hindrances that actually may hinder settlement. So I clipped that. And remain with this layer. So this is just showing the settlement suitable areas where people can actually reside in before floods, or people can actually evacuate in the presence of floods. So onto my dashboard. This is just a River Tana flood impact overview. I decided to visualize flood records in the past 4 years, that is 2022, 2023, 2024, and 2025. So I have the total number of people affected in each year. I have the area affected in that particular year. I have the number affected in terms of graph. As you can see, 2023 had the highest count due to the El Nino. I also have the rainfall recorded in each year. I have deaths recorded in each year, as well as words affected per year. So this tab is basically allowing you to select any year you want. That is 2022. That is 2023, 2024, and 2025. So this is the flood hazard analysis, where I have the total number of settlements affected. I also have the total number of schools in this particular area. I have the total number of health facilities and the total number of roads. So let me just filter for you to see. This is Athi. As you can see, it's changing. This is the total settlements in Athi, that is 4.5K. Total number of schools, that is 5. Total number of facilities, as you can see, there is none. Also, total number of roads, 231. So next up is the Tana River County flood hazard analysis. I have also visualized the data in this particular area. So as you can see, most settlements are actually located in this area. That is the total number of settlements, total number of schools. There is the total number of health facilities and total number of roads. You're also able to filter. This is Garsen South. This is data for the whole map in Tana River County. Let's say Kipini East. Yes, so as you can see, the data is changing according to the words. So my last output is the settlement suitability analysis map, where I have the same facilities, that is the schools. So as you can see, there are only 8 records in this particular area. The settlements, this is the number. The health facilities, there is none. And the roads in this suitable zone is 506. You're also able to filter. Let's say Chewele. So the dashboard is changing according to the record. Let's say Bangale. Yeah, it's also changing where the settlements are only 8 and roads are only 2. So I do believe this project is important and can be used by clients such as National Disaster Operations Center to coordinate, which coordinates disaster response in Kenya. I also believe Kenya Red Cross can apply this project in order to respond to flood emergencies and humanitarian disasters. Water Resources Authority, which manages rivers, water resources, and flood risk. The Tana River County government can also use this for local planning and disaster management. So that is the end for my project. Thank you so much for listening to me. Thank you. So I'll introduce Robert as the next presenter.
Okay, good morning each and everyone in East Africa and above the world, all over the world. Yes, let me share my screen first. I hope everyone can see my screen. Okay, my project is all about leveraging GIS in cashew cultivation. Here we're going to see how GIS can be used in cashew farms management, collection of data, flow of information, and decision making. For those who don't know cashew or who are not aware of cashew, there is a video. You can see it and you also get awareness of it. About myself, I am Robert Beatus Mgaya, graduate of Bachelor of Geoinformatics that deal with land survey, GIS, which is Geographic Information System and remote sensing at the University of Dodoma. Some of the people they call it Harvard of Africa. Okay, I'm passionate about developing solution of different problems that's facing community concerning with geospatial technology. Also, I'm passionate about increasing my awareness, technical skills, and all stuff about spatial technology. My special thanks to Esri Eastern Africa for providing this program of internship. I do appreciate this because I don't know if not you, where could I be? Thank you to all who participated in teaching me, instructing me, guiding me, and all of those things. Special thanks to those who have been giving me their time to help, me in different scenarios through instruction and mentorship for the past 3 months here in Eastern Africa. Special thanks to Ibrahim, who is the country manager, Jovin Inja, who was a solution engineer here in branch of Tanzania, Natividad, Angela, Savai, and Kevin. Special thanks to all of you who are in this panel to listen about my topic. Let's go directly to the introductory part. Uh, Cashew farms, it initially started at Lindi and Mtwara, who were the primary, where it was primarily introduced, and later on it spread to Manyoni, and officially it started around 2019. It's just a few years ago, where the government have been trying so much to push the production, to push the all to make the good environment for the farmers to grow this crop because it's very powerful and it's very good in commercial terms for the people in general and the country at large. But uh, despite of the efforts that have been done by the government, still there are some of the challenges, such as diseases that are facing the farmers, also many other information that farmers are lacking on all of this process of growing cashew crops. There are some of the things that I addressed them, or I faced them as I was finding for the title, and this become the best title to work with, or become the best project to work with. The first problem is the traditional method of collecting information. The agriculture specialist or agriculture officer still using the analog way of collecting of information. This is the use of paper and books. You can see there the man is collecting the information about the tree. So it's, of course, it's a challenge to the to the agriculture specialist in general. Also, the other problem is recognition or judgment and rewarding, so that farmers are not aware of the things or the criteria that are being used to judge the farmers concerning who is the best farmer and who is the worst farmer. You can see there is a meeting, the farmers are just arguing about how did you manage to say this one the best farmer and not this one, because from their views of their eyes they see another person, and who was announced is another person. So it's still a challenge on this crop, also to the farmers. And also the other thing is the flow of information and awareness, that farmers are not aware of the diseases that are facing other farmers or the diseases that affect their fellow farmers. And of course, it's a challenge if you don't know your fellow what challenge is he or she facing. That's probably uh, it might affect you also, and you are not prepared, and so it become a challenge. So through this project, we are going to see how we can solve this challenge of flow of information. You can see there a farmer is trying to recording the disease, and he's not aware of a particular disease, what the disease, what is the insecticide he or she can use, and how to use that insecticide. You can see the other problem about pruning, that the farmers were just arguing, is this way of pruning is well, or it is wrong. The study area of as introduced it area, it's Manyoni district, found in Singida region, all the way from Tanzania. Here is my solution architecture. In back-end part, it involved mainly two personnel who are farm agriculture specialists and GIS experts. The farm agriculture specialist will be using survey 123 form to collect your information. These are boundaries, information about the farm owner, contact of the farm owner, the status of the farm, and many other things. And GIS expert or EGS technician will be filtering the information, removing redundancy of the information, organizing the information, and also we feed them to the database, which is ArcGIS database. And also this information will be accessed through Experience Builder, where it mainly involves two levels. The first level is for the public part, that each and everyone can view the information, but the other part is the part of the people who have license. Here I'm speaking about agriculture specialists and managers of the board, who will be able to view also the information, but will be able to add the information or editing some of the information compared to the public part and the farmers. So the farmers, they will be able to report the incidents about the farm, also to report maybe the challenge that they are facing, or they may request a visit. So we'll see along as we continue with this project. The objectives. The main objective is to provide digital-based solution on data collection, storage, analysis, and visualization to enhance better decision making. And the specific objective, the first one is to enable digital collection and storage of information. The other one is user-friendly data visualization and decision making. The third one is the interaction between farmers, agriculture specialists, and committee members, or the members of the board in general. The desired output is the application that will bring together the managers of the board, agriculture specialists, and the farmers in one place, so that they can communicate, exchange of information, and educate each other through the process of keeping cashew crops. So let's go directly to the demonstration part. Okay. Here is the interface of our application. For the public part, it does not require a person to sign in or to have license. So these are the public information that farmers may access, and also researchers and other public people may access. You can see here it's a map. This map is showing different farms. The color that is used is just used to symbolize from the best farmer to the worst farmer. The one who is in more reddish are the one who are doing best, but the one who the color of their farm is more white are the one that are doing worse on the process of growing crops. But also for the right-hand side, here is the list of the farmers, as well as from the best farmer to the worst farmer. If a person click, of course it's user friendly. So if a person click, it filter other farms and remain only with the farm selected. And also here the farmers or even other individual may able to see the information about the farm. Of course, it's the one that is being highlighted here. The farm status, it is active. Ubuyunga disease, of course, this is the disease that is affecting the cashew crop. Ubuyunga is being affected by 95%, thrips 66%. So the issue of the judgment and recognition on how the board is using to judge the farmers, depending on their performance, all the factors that are used to judge the farmers here will be highlighted. So the farmers, they may be aware on how they can become the best. From there, they can just take the part to know the things and many other things for the information. Okay, let's go directly to the right-hand side. These are the diseases that are mostly taking part, but we can customize it by adding more other diseases, or we can remove other diseases and add this on more information. But here are the diseases that have taken part, have taken into consideration. These are the ones which affect cashew crop at large. So the first one, you can see Ubuyunga disease. Here we'll be able to see how many farms, by how many percent these farms have been affected. You can see 45% of the farms have been affected, that making total of 77%, 77 farms. And those which are not be affected with Ubuyunga, you can see is 54%. Which making the total of 91 farms. So if the person want to know what are these farms that have been affected, you may click here on Ubuyunga. You can see it filter only the farms that have been affected are the ones which will remain, but the ones that have not been affected, they'll be filtered out. You can see also, if you want to see what farms have not been affected, you can see those are the farms that have been affected, have not been affected with Ubuyunga diseases. That is, it's similar likewise to the thrips disease and farm activeness. When I say farm activeness, there are farmers who are abandon their farms, they do not do anything, they not cultivate, they not spray the insecticide. So we consider them as non-active. So you can see non-active farms, they are just 6%. You can see here, non-active farms are those ones which are not active. There are just 6 of them, but the ones which are active, 162 farms are active. And here down below is the panel for information to this it will be able to spread the information about the period they are in the current on the current season, what period, what action they should do, or what thing they should do. You can see here, farmers be aware. Now is the time for controlling thrips and weeds in the farm. So they have to know what season, in which season, and what activity they should do. So this is the part of visualization. And also, as I've stated, that it will bring farmers and managers of the board, also agriculture specialists, to one table so that they can discuss, and farmers they be able to report the information about their farms. So here you can see here it's survey 123. If a person is having survey 123 in his phone, he can use it. So he use Open Survey 123 field app. But if a personnel does not have 7123, we use a browser to address the information. So take an example that the farmer he or she is on the farm and face a certain disease. He is not aware, or she's not aware of a particular disease, and he want to ask for the agriculture specialist what is the disease. So here the farmer will come to fill the name. Take an example, Robert. The phone number, you will fill the phone number here. Okay. That's the phone number. What's the main purpose? the farmer has witnessed a disease. So you say the disease outbreak. Are you in the area? Yes, I'm in the farm. Or you can say, no, I'm not in the farm. So maybe someone called him or her, said, I've witnessed a certain disease on your farm. So if he's on the farm, he will say, yes, I'm in the farm. So name the farm. So the farmers will be registered, so their names will be available. Maybe say, my farm is being registered with the name Robert. 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 So a disease picture, since he has observed the disease, so he will upload the picture. Let's say here is no, this is the disease picture, and he will submit it to the agriculture specialist. So that is all about the public part for each and everyone can see. Here is the information that come from agriculture specialist to their farm to the farmers. So here we just take to see what are this information coming from. We'll see it later. So let's go to the second part, which it require only people with license to sign in so that they can perform many other activities. So let us sign in with our credentials here. As we sign in, here tabs will increase. You can see the tab of agriculture officer and the managers. As I've already explained earlier, that are the ones who will be having the power to sign in. So everything on the home page should remain as it is, and the on the panel or the farmer remain as it is. But let's go to the agriculture officer panel and see what is there. So first of all, let's start with my left-hand side here. These are the information that have been addressed by the farmer to the agriculture specialist. You can see here the request that the problem that I addressed the area is here that here it is a disease outbreak. I have experienced a disease outbreak. My name is Robert, and phone number is there, the date and the time or I submitted this information. So the agriculture specialist, as he see this information, also he will be able to view the disease. If he's well aware or is familiar with the disease, he will address other farmers so that they could know what is this disease. So this is the panel for agriculture specialists to fill for the information. So here, the agriculture specialist or the agriculture officer will fill the name, let's say Innocent. Innocent want to address the particular disease. Maybe this is so you can see what is the disease. You will say that is thrips disease. Okay, we will also attach the picture so that other farmers they may be aware of a particular disease. So what are the signs of that disease? You say maybe of course that is a part of cashew. But for the part of the leaves, you say yellow spot, yellow spot on leaves, on leaves. Also, you say oil like substances on cashew. Substances on cashew. So, what are the areas that are highly affected so that the farmers they may know? So, the areas that are being affected are leaves, the leaves and cashew itself. Sorry, cashew itself is being affected. What is the suggested pesticide? The suggested pesticide is indazole. Indazole. So might be more than one for the particular disease, but for this disease is indazole. And in instruction on how to use it, you will say 1 liter mix with 1 liter of indazole mixed with 20 liters, 20 liters of water. For those who are using 20-liter pump, But for the ones who are using 16-liter pump, you may say 0.8 liters mix with 16 liters of water. Recommended time to use, it's only morning up to 11 o'clock a.m. Quotation, wear mask. Time interval, spray after 7 days, maybe 7 days. And also, he will submit this information to go directly to the farmer. So here, if the farmer will log in again, you can see he will see that thrips, what are the sign, yellow spot on the leaves, and oil-like substance on cashew. Pesticide is indazole, time to use morning, and instruction, here the instruction is spray after 7 days. So what if the farmer requests for a visit on the farm? He will go through the same procedures so that the agriculture specialist may know who requested for the visit. So take an example for this person, Anna, who requested for the visit, and the farm agriculture specialist went to the particular farm and pay a visit. So you want to update the GIS expert about the changes that have been made to their farm. So he will say uh, the the one who had visited, you can say Innocent, who is our agriculture specialist. Innocent. So is the farm active? You say yes. Are you in the farm? Yes. The name of the farm, you say Anna's farm. Anna Farm. What updates about Ubiriunga? Maybe Ubiriunga, no Ubiriunga in general. What are the changes that have been affected? Say yes, there are changes in thrips. What are changes that occurred? It is completely controlled. Maybe Anna once had uh, uh, thrips disease, so he completely controlled what insecticide he has used, because people are being confusing of the insecticide, and also it will help actual specialists to investigate on other pesticide if not the one which used it was not recommended, and but it has completely controlled the disease. So we say he has used the meat force to control the disease. What about the uh, control of weeds? Is it's controlled by how many percent? Can say 100%. Pruning in the farm done. And also he will submit the information to the actual specialist, to the GIS officer. So the GIS officer may edit the information on Anna's farm. So let's go directly to the managers part. Here, managers of the board are the ones who are supplying grants to the farmers to know, depending on the effects of the disease to their farms and other things. So through this dashboard, they'll be able to know. You can see the total number of botrals for controlling Ubiriunga, how many botrals are required for the farmers to completely control Ubiriunga disease on their farms. This pie chart still remain as on the homepage, but I'll explain about the moisture level and vegetation health. So you can see total numbers of bottles for controlling Ubiriunga are 1,185.3. Total numbers for bottles for controlling thrips here are the numbers. You can see them. And here is the list of each farmers and how many bottles he may he will be required to get to obtain from agriculture officer, so that he may control the disease. You can see Brius required say 47 bottles, 0.8. That's approximately 48. And also this Nataraj, he has for Brius does not have thrips. That's why the number of bottles for thrips has not been indicated. But for the Nataraj, number of bottles for Ubiriunga, there are the numbers. Number of bottles for thrips, there is the numbers. So each farmer will be the managers will know each farmer has to get how many bottles and why. So let's go to the moisture level. Yeah, here, of course, moisture level help to determine how healthy are the cashew crops. So from this, the managers may be aware of the moisture level of different farms. You can see the farms with high moisture with their 144, that means they're doing good. But the ones with low moisture, you can see just 15%. So, I mean, 15 farms with a total of 80%. So how these have direct impact to the vegetation health. You can see 152 farms they have healthy vegetation, but those who had the low moisture are the one who are which are doing poor on the terms of health of the vegetation. So we're out for the most of the farmers are using mobile phone. Allow me to share my mobile view. Okay, 1 minute, please. I share my mobile view. Okay, sorry, I don't know what it has happened, but let me share it here. So for the part, or for the people who are having their mobile view, here will be the part for them. For them, you can see here we'll be having the parts. So you can see agriculture home, agriculture officer, farm managers, farmers, managers in general. So the function are still the same. You can see here the list of the farmers.
Robert,
Yes.
we can't seem to see your screen.
Okay. Minute, please. Hope now you can see my screen.
Yes, proceed.
Okay, thank you. So here is the part for the mobile view. Sorry, my phone didn't pop up to show it, but here I decided to use the desktop. So here you can see we'll be having the home page, agriculture officer, farmers, and manager of the board. So the people who are having, most of farmers don't have laptops or computers, so they'll be using their phones to access the information. So here you can see here we'll be having the list of the farmers from the best farmers as it is on the dashboard normal. So you can see Ubirunga disease chart, may be able to see. So all the information uh, will be available. You can see for the farmers, here are the information from agriculture specialists, and here they can comment or they can update the information. So the function is still the same. Function still the same. You can see for the managers of the board, here are the charts, vegetation health and moisture index. You can see here now every individual or farm owner with how many amounts of bottle he will require and many other things. Having said so, thank you for this part. Also, I will give my special thanks to the managers of the board. Okay, sorry, let me finish with my story map. So what will be the importance of this? This will enable the interaction between farmers and agriculture specialists, managers of the board also. The farmers will be able to report the disease or any scenario with the proof with the image proof on how their farms have been affected. And also this will motivate the production among farmers, since the farmers, they will be aware with what issue is facing them. So they may take initiative, maybe for that of controlling Ubiyunga, person may take initiative to control Ubiyunga and many other things. So what are my recommendation for early detection of information, early detection of disease, information of how the disease is spread from one point to another, and many other things? I recommend the Cashew Board of Tanzania, who of course will are the best client for this solution. I may use high resolution satellite images such as Maxa satellite images. Through these images, the GIS expert will be able to define the breakout of disease through using remote sensing, be able to know a particular disease, how it's spread, defining the starting point of a disease, defining the spread of disease, and many other things using remote sensing. And here and there we see the power of remote sensing and GIS in general. Thank you again. Now I will welcome Linus to continue with the presentation. Thank you all.
Okay, thank you so much, Robert. Can you confirm that you can hear me? Awesome, perfect. Okie dokie. Once again, thank you so much, Robert, for that presentation that you've shared. And yeah, I really hope it goes a long way in coming to revolutionize how cashew nuts are actually approached in Tanzania. Well, for those who already know me, allow me to reintroduce myself. My name is Linus Anari, and over the past 3 months, I've had the distinct pleasure. Just one moment. Let me see if I can turn on my video. Awesome. Yeah. Over the past 3 months, I've had the distinct pleasure of pleasure and privilege of interning here at Esri Eastern Africa. And one thing I've come to realize is that Esri is more or less like Thanos to some extent. It's more like it's somehow managed to collect and retain all these GIS experts, Infinity Stones globally. And this is one of the things that I feel deeply honored to have been a part of this particular team. But on a personal level, though, I'd like to deeply thank all those key players during my internship, from my top consultants in the natural resources industry, Tina and Matthew. Matthew has actually been really encouraging because there's a time when I nearly tapped out from this particular project. So my project is about coming up with a decision support framework for hydrocarbon prospectivity. And just as heads up, I have no background whatsoever in hydrocarbon or petroleum. But for some reason, I want to take up this challenge. And Matthew has been one of those people who've been encouraging, as well also the people in the natural resources industry. And also Kevin Kamau with his skills. I feel like as though he's usually too modest for his own good. Yeah, he's too good, but also too modest for his own good. And also the specialist interns, really grateful as well. Dennis and Jackson, you've really been really keen at trying to constantly expand my mind to other ways of trying to approach and address a problem. And also my other key consultants, Dennis Kiogora, um, for your beautiful mind, and also Christine Chege for the many times you nearly threw your phone on my face whenever I tried to be stubborn or try to come to think of an average solution, which also challenged me and made it particularly difficult for me to think of any average solution. And also, Ronald, your charisma, Majoek, all your genuine free compliments and advice. And yeah, last but not least, I think our facilitator as well, Joyce, for your immense support and patience with us once again. But yeah, so my project is about the GIS-based decision support framework for hydrocarbon prospectivity. So just a background, hydrocarbon refers to anything that contains both hydrogen and carbon atoms, referring to the LPG that we use in our homes, referring to petroleum, that is petrol or maybe diesel and all that. So prospectivity is more about how they are explored and also mined. To just speak a bit about my profile, I'm a geospatial engineering graduate from the University of Nairobi, and I've had the privilege of participating in several projects and hackathons spanning from urban planning to food security to coral restoration to noise pollution to land degradation. But I've particularly found my peace in the natural resources and environment in general. And other things that I usually do is that I'm also a Joabari podcast host on the Young Professional segment, which is one of the things that I'm particularly proud about. I'm a Google Earth Engine trainer as well. I've been doing that since I was in third year. And also, I volunteer several times for the Space Generation Advisory Council, among other things as well. Some of my interests is mountain biking. Definitely, I love that. Traveling, I'm a sucker for that. Reading as well. I enjoy discussions about space. I do a couple of designs using Inkscape, Canva, Photoshop, and many other softwares. And also, definitely, if you see any hackathon, please feel free to sign me up for it. No need to ask me, no need to ask for my position. Just write my name there. Okay, okay. Now let's just dive straight into today's actual topic, the challenge. So here's the thing about our offshore basins. It's so easy for people to mine on land, and this is because there are a lot of data that has managed to be obtained from land, including survey data. Like the entire of Kenya has already been surveyed. We have the rocks and minerals data. We have the terrain data set. We have a lot of data sets on land. But when it comes to the other side, which is offshore, basically meaning on the surface of water or in the oceans and everything, it's particularly difficult because as you move away from the shore, it's hard for you to establish controls or maybe come up with survey data for you to be able to maybe do your seismic surveys or bathymetric surveys and many other surveys that you need to obtain the data for the bottom of the ocean so that you can actually know where oil could be found, or rather hydrocarbon in this case. And this makes it really, really expensive to do exploration on the offshore side of this field. And this is what brings up the whole aspect about why it is really, really critically important for us to be able to make better decisions in such a data scarce environment. My area of study was in the Lamu Basin offshore blocks, which is basically the entire EEZ zone of Kenya. And the objectives was first, just for the record, this is a proof of concept, okay? And the objective was to just to develop a GS-based decision support framework for identifying potential hydrocarbon prospectivity zones. Where exactly is there a likelihood of getting hydrocarbon on the offshore side of the Kenyan coast? And this was to be achieved through a couple of specific objectives, including integrating of several key geological proxy datasets, because I'm calling them proxy because there are other better data sets that should be included when it comes to prospectivity of hydrocarbon. And this involved sediment thickness, bathymetry, and magnetic anomalies as well, which usually play key roles when it comes to prospectivity. Just to give you context, oil usually ends up being trapped inside sediments. That's where they are usually stored. And for it to change from organic matter to oil or gas depends on the amount of weight that is on top of that sediment. And this is where the bathymetric data comes in. So if there's so much weight on top of it, it's gonna heat so much until it becomes gas and escapes onto the surface of the earth. And if it's and if there's less weight or bathymetric data in this case, it won't have enough heat for it to change from organic matter to petroleum. So it's critically important to find that sweet spot where it's the perfect amount of weight for it to transform from being an organic matter to being the hydrocarbons, so petroleum or gas. And last but not least, the magnetic anomalies, because there now needs to be like a cap that prevents it from escaping towards the surface. And magnetic anomalies data is the perfect proxy to establish that. And next was to try and use and apply, fuzzy logic technique to try and standardize these particular layers and also incorporate other data confidence assessment layers reflecting the reliability and resolution of input data. This involves trying to come up with, questions about what if this particular model that we've come up with was uncertain? What if it made a mistake in trying to level them out? And last but not least was now to evaluate the model robustness by using now the Monte Carlo sensitivity analysis to account for uncertainty in weight assumptions. My solution architecture took quite an interesting turn. Sorry, I'm using two screens. Yeah, took an interesting turn here because first we had to input all these three proxies or the geoscientific or geological data sets. That was in ArcGIS Pro. Then the different outputs that came out of it were used now to come up with the decision support output. So from prospectivity to confidence to uncertainty, like how uncertain was this particular model, among others. Then it was then pushed to the cloud, in this case, ArcGIS Online. Then yeah, from there we have the user side where now it was open for the stakeholders to be able to access and utilize it. And by the stakeholders, I'm referring to the marketers and both the regulators. This is the State Department of Petroleum, or Shell, that is the marketer side. Shell, you've heard of Tullow Oil in Northern of Africa, among many other key players in this whole industry. Yeah. Just to kick us off, when I was referring to the fact that every single data was crunched up in ArcGIS Pro, the first bit was to come up with this model builder here, where it was just as simple as just inputting the three different data sets, as the magnetic data set, the sediment data set, and the bathymetry data set. And for the record, these are all global data sets publicly available. The magnetic was from EMAG, the sediment was from GlobeSed, and bathymetry was from GEBCO data set. And we found the fuzzy membership of each and every one of them. And yeah, we got the outputs, which later on went to the final screening model. Then next year came up, I did write this particular code, which was an easier way rather than having to repeat the tools over and over again. Using Python script within ArcGIS Pro actually does help you automate and ease in your work, especially when it comes to repetitive work over and over again. So I loaded these particular datasets that had the fuzzy datasets that had already been produced from the previous model builder, which was used now in the next steps of the process. So as you can see, we did have this uncertainty model, as I was mentioning, where it's just supposed to tell, what if this particular model was wrong? Just that aspect of what if. That's the whole aspect about using Monte Carlo analysis. It introduced that aspect of uncertainty, trying to account for all that. So we defined it by perturbing every single layer with a 15% uncertainty. So every single output I ran, by the way, for 1,000 simulations, and every single simulation was trying to introduce 15% of uncertainty. What if this layer was, 15% off? What if it wasn't that right? And that is what was taken into the Monte Carlo simulation. All those simulations ran successfully, and the statistics were obtained. Now, from these statistics is when now we came up with the mean prospectivity raster, which was basically the mean of all those 1,000 layers or 1,000 simulations or 1,000 outputs that had already been computed by the Monte Carlo one. And every single time those particular pixels or those particular areas that constantly fell on the high prospectivity is what was now used to produce that particular raster or that particular map. And this was just to try and make it robust and statistically accurate and reasonable when it comes to prospectivity. Then from there, we had the frequently top, those that appeared in the frequently top 10%, highlighted there just to show the areas that constantly were featured as to be having a high potential for hydrocarbon. Then we had for the value of information map. So the value of information map is, what is it? Like, it is a petroleum term that is usually used and it's a decision analysis critical information, just to refer to areas that the model might not have been sure about its output. And for that reason, we do need more information there, or rather more survey to be done there, so that we can refine the data for the model to give us better outputs about a particular area. And yeah, that's how we ended up getting our particular outputs. And I validated using the current existing wells on the offshore, which I'll demonstrate later on. It was really, 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 really encouraging, considering the fact that this was a proof of concept. And yeah, but last but not least, the success rate curve. I won't really trust this because we only just had a few wells. The Kenyan offshore hasn't really been explored that much. And yeah, from there, we came up with the drill recommendation zones. So the areas that consistently fell on high prospectivity, as well as also fell on the top 10% of the Monte Carlo analysis. Then last but not least, it was the exploration risk index, which is used to is used on the side whereby in case we need to go do prospectivity, this particular, if we need to go explore, or rather do go mining, what are the risks that this area could not actually be having hydrocarbon? The risk that in terms of how much, are we just going to spend so much to get so little? So that's where this particular layer also came in. So at the end of the day, it was a wholesome, more or less, of a decision-making framework to be used by any key stakeholder out there. So I'm just going to show on this other side now, once all this analysis has been done, the user side of it, how helpful does it come across? And this was the particular interface that was built by Esri's Experience Builder. And on the first, on the first tab here, we have the expected hydrocarbon prospectivity. And what this one is basically displaying the areas that, according to the 1,000 simulations, which areas seem to be having the prime exploration targets, which ones seem to be having very low, prospectivity. And as you can tell, as we move away from the coastline, the prospectivity keeps dropping. And on this area here, there seems to be more or less like a sweet spot of prospectivity, and these are the prime exploration targets as per the 1,000 simulations that were run. But now the next layer brings out this other aspect of, what if? So in case, let's say you want to check out the L8, this is for any key stakeholder who might want to use it. Whenever you search for L8 here, the block name, it pops up there and brings up the name, the area in square kilometers, and also the status in terms of its prospectivity for each of the layers. But now the next layer brings up the aspect of what if this prediction was not as accurate as is being purported to be? And this is where that layer now comes in, where this particular layer tries to display where is it that the model was very, very certain about its prediction. Where was it very accurate? It had no doubt about it. And the areas that have really deep green outputs are the ones that show very stable prediction. And this is because of the standard deviation that was obtained from the model. So the areas that had low standard deviation clearly means that it had a very stable prediction. And those that had really high standard deviation, as you can see here on the red zones, had very, very uncertain. And hence it means that there needs to be more data here for it to try and maybe improve on it. Then we have this other area here. Sorry, let me disable this block name here so that we can zoom out. Exactly, perfect. Nice and easy. All right. So we have this other area where it was the persistent exploration hotspots, basically all the areas that were on the top 10% of the Monte Carlo analysis, like the 1,000 simulations that were run. Then we have next the value of information for exploration data. So as I'd mentioned earlier on, value of information is basically a term that refers to which are the areas where, in case we want to explore there, we might need to have more information, or rather do a bit more of research, or maybe go get more data for that particular area so that we can be sure about it. And the areas that have a deep brown coloring there or label was used to refer to the low information value, such that these are the areas whereby, in case you go there and start doing maybe your seismic surveys or your bathymetric surveys, the chances of you getting a different output are really, really low, because the model is particularly sure about that area. It has constantly been confirming. And as we move out the relatively lighter fade of brown, that's the area for limited exploration benefit, and so on and so forth. And we have all the way to the priority for seismic surveys, which is on this area here. Means that despite the fact that the model might have said that there could be a chance of like that area might not be having hydrocarbon, it also saying that there could be also a priority for seismic surveys there, so that we can try to improve and refine the data there for it to get better outputs. So just to remember again, this is publicly available data, so it's not localized, it's not refined to this particular show of ours, hence why all these analyses are of great importance to come up with this. So from all these particular outputs is when our blocks, so the Kenyan offshore is usually divided into several blocks for prospectivity reasons, such that there are areas where they have high prospectivity, or rather, let's say Shell wants to come mine somewhere. The Kenyan government needs to give them a certain block for them to mine or to explore. Yeah, so that to avoid all this conflict. So you can't get Tallow and Shell inside the same block unless maybe they decide to partner and all that. But yeah, each and every marketer is usually assigned a single block along this particular offshore basin of ours called the Lamu Basin. So yeah, from all those outputs, we ended up coming with this ranking for the top priority blocks, the ones that have a high potential for hydrocarbon prospectivity, and they're the ones that are marked with a deep green, which refers basically to the ones that should be given priority when it comes to bidding or licensing, or maybe even given a higher price when they are bidding out to the different marketers to come and do their mining for prospectivity there. And the ones that have close to a white or a really, really fade of green are the ones with the low potential block. But also, this doesn't mean that this area doesn't have any hydrocarbon, but could also refer to the fact that there is need for more information here, as you can see from the value of, as you can see from the previous outputs that these are the areas where the model wasn't sure because the data there wasn't as good as the ones next to the shoreline. And yeah, for now, this is the output that it provided, but there's need also for more exploration on this side here, deep inside the waters to improve on the outputs for that side. So yeah, from all those data sets, we had our drill recommendation areas, which the model outputs showed the areas that are recommended for drilling. That's after following all the 1,000 simulations, getting the mean prospectivity, and also combining other layers as well. And when the most interesting part is that when you try to outlay with the current wells that exist on the Kenyan shore, this is where I was particularly proud about this model that I developed. As you can see, this is, let me close this one. This is a well that has been built and contains oil and gas. And when you zoom out, it falls perfectly and at that sweet spot of the prime drill location. And when you zoom out and maybe look for this other one here that has gas, falls on the moderate drill location. Whereas for the rest of the red ones, which are currently dry wells, these are wells that they were dug, but after a couple of maybe months or so, they realized that the well never really had any hydrocarbon, so they had to abandon it. They do fall on the poor drill potential and also poor drill potential, poor drill potential. Name them all, come on, poor drill potential as well. And this is one of those reasons why the use of GIS or geospatial technology can actually be used to save on tons of billions of shillings of investment money when it comes to prospectivity. So combining all these layers does give a heads up in terms of guidance on where exactly to focus on when it comes to prospectivity. And now imagine if this was used by public data. What if actual refined data was used to come up with this model? I'll leave that question to you. Thank you. That has been all from me. All right, I think I'll Michael Miriti, over to you.
Okay, thank you, Lena. That was a great presentation. I'm about to go next, and let me just share my screen now. Okay, my name is Michael Moreni Militi, an intern at S3, and I'm a graduate from KC University. I did my bachelor's in information technology. Currently have a solid interest in GIS as given my peers here had a background of GIS, I was challenged and I took it upon myself to get it as a task to do. My key interests are hiking. I am a hiker, a very good hiker, and things to do with technology, anything dealing with technology. Should it be cables? Should it be devices? Should it be underground digging? All that from Ethernet cables to what have you. Feel free to contact me. I also did my diploma in JQuad. I'm currently thinking about pursuing a master's in IT as well, and have some more 2, 3 certificates on GIS. Wouldn't be so bad. Yeah, that's all about me. And first and foremost, I'd like to thank A3 for giving us a chance to showcase our ability to work at the company. The team at large, Joyce, our very able coordinator, Latima, my supervisor. Special thanks to Kevin, Dennis, Jackson, Maxwell, and Steven for joining with us throughout the project. The project, of course, wouldn't be a success without your input, guys. A huge thanks to my peers, Linus, Shadrach, Clinton, Bridget, Robert, Desiree, and Samuel. You guys, you've really had an input in our projects. We've been picking one or two things from each of you, and it has come a long way in helping in finalizing this final presentation that we have today. With that said, I'm going to take you guys through my project. So I'll pose a question to you guys. What comes to your mind when you have, or rather when you hear the term revenue or revenue collection? I leave that to you as well. So allow me to take you through revenue collection optimization system for Kiambu County. First and foremost, I came about to this project from the concept of entrepreneurship, which is more or less filling gaps that are existing in the market. So I spotted a gap in terms of revenue collection because when it comes to the physical actual revenue collection, talk about when it's time to actually validate these permits and what have you, I noticed there's a gap in the system whereby the revenue authorities are just sent out to just go and certify permits, and mostly they don't really have a huge scope to cover, which is a huge gap that I spotted and wanted to fill. So hence came up with this project. So why GIS revenue optimization? So as you all know, revenue is one of the key inputs when it comes to development and what have you, when it comes to infrastructure and basic developments in our country. So revenue is one of the key points that you need to focus on. And I took it upon myself to actually have it as a project. Yeah. So we're going to measure on property rates, business permits, parking fees, markets, and outdoor advertising. These are mostly high revenue collections points, or rather hotspots, because they have a huge inflow of population coming in and out. Like I'll give an example of Nairobi. We have an inflow of 7 million people a day. So try and tabulate that when it comes to bus stops, parking areas, and what have you. So I narrowed it down again to Kiambu County because, as you all know, Kiambu is one of those rapid developing counties. And we had a discussion amongst our peers, and I'm sorry to say I lost majorly because I was more or less supporting Kiambu to be our next CBD, or rather our next capital city. Because given point to point, Kiambu is quite big and it harbors major cities, major towns. We have Thika, we have Juja, we have Ruiru, and it stretches all the way to Maimahio. I'm sure most of us didn't have that in mind, but Kiambu is one of those rapidly developing counties, and as a result of that, we need to tap in. So you can see you have those towns that are familiar, as you know, Limuru, you know, Ruaka, Kiambu, the very upcoming city, Tatu City, Juja, Ruiru, and what have you. So basically, this area, Kiambu in general, is an area that you need to tap in when it comes to revenue collection, because given the amount of population that's coming in there, we really need to focus on, okay, just a minute. Sorry for that. My screen went sort of disappeared a bit. Yeah, the challenge you have in Kiambu County, it comes in whereby you have manual processes of revenue collection, outdated or incomplete revenue asset data, you have limited spatial oversight and inefficient field operation. This comes in whereby, let's take for instance, the revenue authorities at Ruiru. If they're sent out to go and actually validate the permits that you have in businesses, they're limited to a scope because they don't really have that data that they need to use when it comes to revenue collection and actually certifying that the permits that are given out there are actually what is there in the system. So I took it upon myself to come up with this system, and on my screen here, I'm going to take you guys through two bus parks. On the left side, you have Green Park. Let me just out for you guys to see. This is Green Park. This is a bus park that is there in Nairobi County. And this is Kwambira Bus Park, an upcoming bus park that is there in Limuru. So Kwambira actually started, let me say, like a story, if I may say, but they filled some gaps that I don't know if you guys can pick it out. Basing on what we're seeing here in Nairobi Green Park, we have just bus terminals and advertising posts, some of those key points that I've actually mentioned. So when you look again to Kwambira, we have stalls that are actually here and they're not there in Green Park. Another case study is the very popular Nairobi bus station. So this is the area I'm talking about. If you guys can actually see my cursor, we can see some buses that are parked here and not really much activity going on here. So this is some of those gaps that I was speaking about, because from these spaces that we have here, Limuru, as I mentioned, took it upon themselves and came up with a bus park that has actual shops that are existing in the bus park. So it will be a win-win situation for the county in this sense that when the passengers come to board the vehicles, we know that there's normally a queue and all those formalities that are involved there, waiting for the bus to actually take off. If it's a long journey, you need to have your refreshments. Maybe you need to buy some shopping, some 1, 2, 3 things that you may have forgotten from the shops. So that's why, as you can see here, we have a shopping mall, we have a restaurant coming here, some shops, and even a college. So these are some of the businesses that are actually coming up, and it's not really structured. That's why we had Kwambira come up with a structured system whereby the shops are actually mapped out and available to the public for them to actually have to display whatever they have. So as a result of this, we can all agree that this area will come up very fast. Things to do with the roads here will be amended. Drainage system, as you can see, still in line. And also you'll have a common police post here to manage and control the population that will be flowing here. We can also have a common market that will actually come in and major business opportunities for anyone to venture in on top of the stalls that are actually given out here. So all this came in as a result of that concept that I just mentioned, entrepreneurship, which is majorly filling the gaps that are there in the system. So this was a gap that was there in the system because there wasn't really that much controlled operations when it came to bus park monitoring and the bureaucracy involved in that. So Limuru came up with that, and let me just show you guys how Kwambira was initially. Just to mention again, Nairobi bus station is in Nairobi County. Another area of focus that we took was Kwambira. Let me just show you guys what is speaking about. All right, there we go. There we have Kwambira bus park. This was how it started. Just a slightly updated map of Kiambu County, but as you can see, it was placed strategically at a junction. So just give it a thought. Imagine if we have a bus park at a junction, this population that is coming in here from the left to the right side, this area here, there'll be a huge development. I'll give an example with Nairobi again. The common buses that we know, the super metro. As you know, right now, it's more or less taking over almost all stages, which is a good thing. And we want to also open it up for other stakeholders to look at it as in the same perspective. So this was an area that was just left out, government property. So they fill this gap by having a controlled bus park, and this will help when it comes to revenue collection, because the bus parks are actually going to pay some fee for them to actually park there, and the passengers who are going to board. So we know that we have a strategic way on how these guys normally determine the fares and rates that are actually paid by the passengers. And having this, the passengers themselves are going to benefit in a way that you won't have to really stress out that much when it comes to those times you need to travel. So it's more or less a system closely bordering the airport system where we have shops inside the airport. So this is another area that you need to tap in because as you can see, Kwambira here we have these are actually lorries that transport groceries and what have you. So from this, I think we can all agree we'll have a common market. This area can actually be redefined as a commercial area or even an industrial area from all the activities that are actually going to come up from there. So yes, on to my solutions architecture before I take you guys through another part of the project. So on the right side, we have some steps that we're going to talk about when it comes to the permit and digitization aspect of it, and also the geocoding part of it. On the right side, we have the steps that I took to come up with this project. So on the farthest bottom, we have the access roads and highways. I took this because, as I mentioned, the influx that we have in Nairobi, about 7 million people come inside Nairobi, in and out. So you can imagine that's just Nairobi. What of Kiambu? Definitely the numbers will go a bit higher. So that's an area that you need to tap in to help in terms of revenue collection and also tap into other hotspots when it comes to digitizing and monetizing the workflows. Next, we have the ArcGIS data reviewer. This is where we validate and geotag the coordinates with the actual location of the businesses. Just to shed some light on what I've said there, we can see some icons pop in here. Just a minute. So these are all businesses. The black icons are all businesses, and the purple icons are new businesses. So the purple icons came about, or rather the purple icons, which are the new businesses, came about from the existing, or rather the pre-existent businesses, which are the black icons. In what aspect? I'll give an example with S3, where it is. We are located at Cusco Center, and just next to us, we have TSC. Then we have a road in between, which serves as a junction heading to Jubilee, Talanta, and what have you. But in between there, we have some kiosks and shops that are operating. We have the smoky vendors, we have fruit vendors, and shoe shiners, and what have you. So we get these guys normally have a challenge when the county authorities come in, whereby they just have to scatter and disappear because they are not really operating legally, if I may say, but we're trying to tap into the system and actually help them benefit and also have a plus to the government when it comes to revenue, in a sense that these businesses are going to be mapped. So they're going to be geotagged and coded in a way that we are going to have a portal for the revenue authority guys, whereby they're going to see these businesses that are existing and the new ones that are also going to be popping up in the system. So this will help in a structured way whereby when it comes to revenue collection, going to have things like if they're going to look at the kiosks and the fruit vendors and what have you, they can have a tile or rather a schedule whereby today we are going to deal with the car washes, tomorrow we're going to do the kiosks, the other day we're going to do the fruit vendors and what have you. As much as these small business entities don't really look like they add much value to the system, just look at the numbers, and numbers don't really lie. I'm sure, right? Everyone where we are right now, if you just look outside, you can just spot any shop that's existing there. Believe it or not, we can be having a permit there, but it's not really that much of help to the government. So this system comes in whereby we're going to optimize these workflows and actually help the vendors and the government both reap out of it. So we are going to have this system whereby we're going to use the digitizing aspect whereby NTSA actually started it and we're going to follow in line, whereby we did away with the red booklet and came up with the digital licenses, which is a card with a SIM or with a chip embedded in it. So putting this into practice, the permits that we have right now, we're going to sort of revoke them and the new businesses are going to re-register and fill a form whereby they're going to have, instead of the long permits and what have you, going to have more or less like a digital permit, having a barcode with all the details that has the businesses and what the business entails with. So this will help in a sense that the revenue authority guys will have the businesses mapped out for them to see this business exists. And when they go to the ground to actually validate what is happening, they're going to have a tile whereby they have the businesses on their side having been registered. Let's give an example, like we have a supermarket, let's say Kamaki's supermarket. Kamaki's is an area in Kiambu. We have Kamaki's supermarket on their portal, and when they go to the ground, they won't actually see Kamaki's hardware, they'll see Kamaki's supermarket. So this will be a plus to also the business people, whereby we'll have the businesses registered, and I'm sure the government will come up with a way, but that's going to have structured ways to actually have more input to them and help them maximize on whatever they're dealing with. So some of my objectives, the main one will be to develop a GIS-based system that maps, analyzes, and optimizes revenue sources in Kiambu County, enhancing collection efficiency, reducing leakages that you just mentioned, and enabling data-driven decision making based on the portal that we're going to have for these guys. My other objectives are we're going to map revenue assets, businesses, land, properties, market stalls, parking zones, and billboards. As I mentioned, these are some of the hotspots that are quite essential to the government, the county government at large when it comes to revenue collection, as they form a key aspect in terms of development. Also going to design a geodatabase for accurate storage, maintenance, and governance of revenue assets. Going to analyze partial patterns. This includes the hotspots, the clusters, and undeserved zones. Undeserved zones are those just government properties or government lands that are just there that are yet to be tapped in. Can give an example with what you have here in Green Park or even Kwambira Bus Park. The area was just there, it was land, but they tapped into that gap and actually filled it. Also going to detect the leakages by reconciling mapped assets with existing county revenue assets. This is where I've mentioned the current shops that are there in Kwambira Bus Park. So when you put it hand to hand, we have Nairobi Bus Park, which has not really a structured way on monitoring the businesses that are there. And on this other side, we have Kwambira. So it's also a plus. We're also going to build interactive dashboards to monitor collection performance and compliance. We'll show you guys that in a few. We're also going to deploy field tools, active field map for continuous real-time updates. This comes in whereby you just mentioned the businesses are going to have real-time updates, whereby the revenue authorities, or rather the guys mandated to collect this revenue, are going to have a portal whereby they're going to see what's actually happening and what the businesses are actually doing, and actually have a number whereby they're going to know we have this number of businesses. This is the amount of revenue we expect either monthly, daily, or even yearly. So this will help when it comes to planning for development purposes and what have you. Let me take you guys to my dashboard just to shed some light on what we just mentioned. So yes, this is the dashboard I was speaking about, the dashboard that is going to be there for the revenue authority guys. So these are the businesses that we have, and here they are mapped out one by one. So this was the collection, the general business and the names that we have, whereby let's say the guys at Juja want to do the certification of the permit, of which now we are speaking of the digital permit, whereby we have, let's say, let me give the same example, like Juja Supermarket. The owner of Juja Supermarket applied for a permit, whether it was a new business or an existing one. So if it was an existing business, when it expires, which is normally given a yearly period, when you renew, you actually going to have a system whereby you're going to actually renew it online and have this guy come to your shop to physically assess what you're doing and what you've actually submitted. So having that in mind, we're going to have the retail, the bakeries, the construction. These are basically all the business types that are there. Just to shed some light again, this is dummy data that we collected, but based on the current trajectory that is happening, the rise and fall in the economy, but this is a steady trajectory in income. So we have a collective figures here from the retail, the bakery, and what have you. Then on just next to it, we have the businesses individually. So let me say, for example, we have Kamwangi Hardware. So in tough one that we're going to have it zoom in, and this will actually help the revenue guys when it comes to physical assessment, whereby they're going to have this place mapped out the coordinates there for them to actually go to this place and certify what the hardware is actually dealing with. Because when it comes to business operations, we have those tricky characters that actually say maybe they're dealing with hardware. When you go there, we have an aggregate shop. So just to start again, this is the portal that the revenue authority guys are going to have with the projection and what they're actually collecting. So when you look at it, we have a gap of around 5%. This is a gap that we're trying to fill because initially from this system, we're going to have just a small margin, which is around 200 million. Not bad. So this 3.1 billion comes in whereby, let me go again to Kamwangi. On my far right side, we have the daily revenue, the monthly revenue, the yearly revenue. So all this will be based on the type of businesses that are operating. So I can say that the daily revenue we can maybe classify to the small business ventures, the monthly revenue going up like that to the yearly revenue. But basically, you can have it collected for yearly revenue. The monthly and daily revenue collection is just for planning purposes because we have those businesses that are not really fixed at one point. So here we have the coordinates here to know where exactly it is. We have the daily revenue expected and the monthly revenue. So the county guys are going to have this portal whereby, let's say today being a Tuesday on 24, they're going to say we're going to deal with all retail sectors and maybe bakery sectors. So they're going to have a location, a physical location and a platform whereby they're going to have all retail shops, all bakeries, all car washes, and all maybe dairy farms that are going to choose. So it will be solely on their side to decide which business venture or rather which business types they're going to validate today. And this is actually a plus whereby for those businesses that are existing and are not really following up on their permits, they're going to be tasked with actually having to follow up on it because failure to which what normally happens when you don't have the permit being active. So yeah, that was the dashboard that I came up with based on dummy figures. But as I mentioned again, this was a smooth trajectory of what is currently happening. So for the deliverables, we have a comprehensive revenue asset geodatabase, which is a well-organized access geodatabase containing all mapped revenue assets in Kiambu County, including the business locations, compliance attributes, which are the permits we're speaking about, the property parcels with rate information. These are the monthly, daily, and yearly revenues, billboards and outdoor advertising assets. As you've seen in Nairobi Bus Park, this is something that is actually going to be implemented in Kwambira. The parking bays, the parking zones, market stalls, and trading points. These are some of the things that we've actually seen in Kwambira Bus Park, whereby we have these stalls coming up here and the parking stalls. Sorry for that. These are some of the key areas, or rather, the not really explored sectors when it comes to revenue collection and optimization, but they really have a major input. We're also going to have interactive web maps, a set of active online web maps displaying distribution of all county revenue assets, registered versus non-registered or non-compliant assets. So this comes in whereby we just mentioned the black icons are the old businesses and the purple ones are the new businesses. So when you see a business on this map, when actually it updates live, we're going to know that this is a certified business. So we're also going to have a revenue optimizing dashboard. This was the dashboard I was speaking about. So without selecting, we're going to have the map displaying just like that for you. So when you just tap onto any business, you're going to see it there. Next, we're going to have field data collection tools, which I use when it comes to coming up with the whole project, which was the field verification of business properties, who are the revenue authorities guys we have, mapping new revenue assets. These are the new business location, updating existing records with GPS accuracy. This is whereby I just mentioned we're going to have the businesses pop up live to their portal so that any business that is either new or old, they're going to have their permits digitized. And this will ease the burden on the county revenue guys because it will be an easier task for them when it comes to actual validation of the permits and what have you. So having that said, this project will be of key help to the KRA board when it comes to revenue collection. That is at large, and we can actually upscale it to other counties. We have a similar system which is called Nairobi Pay, that is there in the Nairobi County. So the revenue optimization system for Kiambu County is just majorly focused on Kiambu, but we can actually upscale it to other counties. Without further ado, that was my presentation. Thank you for your time. Next up, I'd like to introduce Shadrach.
Yes, thank you so much, Michael. Allow me to share my screen. All right. Thank you so much. Good afternoon, everyone. Welcome to my presentation for those in Eastern Africa and around the world. My name is Shadrach Winter Dorendolo. I'm an aerospace engineer, a GIS specialist, and I am also a UAV consultant. So yes, today I'll be briefly taking you through my service that I spent time creating here at S3 Eastern Africa. More about my experience here. Well, when I first came to S3 Eastern Africa, I barely had enough knowledge regarding aeronautical information management, and I was pointed to my supervisor, which is Christine Chega, and she guided me on different certification courses that I did at the beginning that guided me on coming to a decision on what I'll be doing as a project. Aside from that, I consulted the CTO, who is a solution manager, Mr. Sydney Nyongesa, and the director, Rachel, and they told me how different departments run here that pointed me through customer success, which was run by Angela, the commercial team by Max and Joyce, the government, which we have the lead Deborah, Kevin Kungu, and also the natural resources department with Kevin Kamau and Tina. Aside from that, I had advice on satellite usage from Dennis Kiogoro and the specialized interns Jackson and Dennis. I'm grateful to the entire team as they continue to guide me into understanding how I can improve my service and who will be the main beneficiaries. So yes, my project is on mainly data analytics and progress tracking for airports. And the question you may ask is, why do we perform obstacle analysis? Well, the main goal is to ensure that nothing penetrates these protected airspaces or air zones which are critical for safe aircraft movement. And aside from that, we'll run a demo of data collection and visualize this data in 3D that would later on be approved and checked for risk mitigation while planning for emerging responses. So technically, there's no single safe height or fixed height for any building. And we usually say that the further building away is, the taller it can be. And some structures have been there for a number of years, and we want to ensure that aircraft can still fly safely. So we need a robust, time-bound, and safety-conscious service that bridges the gap between the clients and the contracting companies who may be having cranes, for example, while reducing the resources of having field agents going around to assess these areas where procedures may be carried out. So I've created an app known as Discovery that has the following capabilities. So on ArcGIS Pro, we'll be having surface generation, and we'll be able to create a platform from 2D to 3D that will have all the point data and polygon data, depending on what we are assessing. At the same time, we are collecting data via survey 1 to 3 that will be displayed on the experience builder. I've also prepared a code that I'll show in my demo that background checks according to the International Civil Aviation Organization standards that any of these structures within or outside the airport are following the regulatory compliances. Internally, we also have runway inspections and any other airport procedures. To continue on this, my main objective, as mentioned before, is to ensure that we have a redundant system that replaces manual surveys and technical offline expertise with real-time automated ICAO-compliant data tracking and asset management services. So this is shortly the step-by-step procedure of how my solution will run. And we're ensuring flight safety, improved airspace management, and support for airport planning and expansion. Jomo Kenyatta International Airport is my area of focus, and it's the 6th to 7th business passenger airport in Africa. Here below is my solution architecture, which focuses on how I worked on ArcGIS Pro to come up with this solution that initially I thought we can have a cross-cultural platform, or rather a platform that links where we work on Pro and have the service run online. And if there are any technical support issues, we may address them. However, it is better to have this solution only online, as experts in the field may not be conversant with ArcGIS Pro, or at the same time may not have time to go through different systems to understand how they work before they apply them. So I integrated all the layers we had by sharing them online, and at the same time, any tools we may have that may run on scripting, be it collection of the label of the company, the name, the date, the type, or the direction, and I ensure that I merge them into an online system as shown below. Clients will be able to assess contractors' details via survey that's submitted, and the ICAO system will be checked by the code, and alerts will be sent via email, after which clients can now proceed with applications for approvals by the airport's authority, in this case being the JKI. So yes, we have different surfaces that have been generated on Pro, and the person I would like to show is the horizontal surface. I don't know if it's visible. One moment. Yes. So we have the horizontal surface that's shown here. We have the transitional surface, which is within the airport near the runway. The inner transitional surface, which is where the runway is. We have the bulk landing surface, the conical surface. Now, this covers the area just around Jomo Kenyatta International Airport, and we may have procedures happening there. So we also want to ensure guys are within the laws. We also have the approach surface, and below is an image of what you get as a 3D of, let's say, the terminal area, Jomo Kenyatta International Airport. And this can be used to assess how high the structure is, and we can proceed with obstacle analysis. Yes. So as described below, this is how the system will run in terms of a web service, and the clients will have ArcGIS Enterprise and be able to log in online. At the same time, the contractors will have the feature service, which also encompasses a geoprocessing service. So that is the trigger event of applying and receiving the email. And the webhook sends a payload that alerts me, if I'm the case of the client, the airport authority, that my contractor has received an email and should follow up. There may be other major methods that you may think are relevant in coming up with this solution, such as using satellites. So you can do so, although you're limited to an image that's not clear per se. We have the buildings as shown, and at the same time, to process this, you'd need to download certain files within your computer and environment variables to ensure that this doesn't take time to load. So it wouldn't be feasible to encompass this into my solution, hence why I chose the method I did. Aside from that, we're able to assess how far buildings are from the airport and what they need to have. Let's say radio navigation lights. If they are 45 meters away from the airport, they can have the red color. It's about 100 meters, 250 meters should be one white. Should be the white color. We're ensuring that also any clients that will take this solution will be able to reach out to the contractors and process the applications within a day. On top of that, we are adhering to the SDG goals, which would be on industry, innovation, and infrastructure, and the partnership for the goals as I provide this solution. Possible adaptations of this solution would be throughout Eastern Africa once it has been adopted by the Kenya Airports Authority and maybe the Uganda Civil Aviation Authority and also that of Tanzania. So yes, we may now go through the solution benefits. And as you can see, so far we have 98 contractors who have registered, and we're able to see them on the map. If, for example, if you click on an approach surface, you can see who this person is and at the same time the data about them. We're also able to use this for validation to see how many clients have been authorized and match the system with hard copy data that we have, for example, as the clients in the offices. At the same time, creating an internal system for the staff to include anyone who is not in the system who wasn't registered. Another benefit would be what you'd call commercial on the shelf, which is you're taking systems and parts of new technology and adding them onto an existing technology. I can give an example of drones. For example, you can have a camera that has LiDAR detection or radiation detection or thermomechanical features. But the issue with using the courts is we need to also meet airworthiness standards. So we need to develop legal procedures, binding comprehensive documents that will be published in the National Aviation Authority. And this would be included in the AIPs, which are aeronautical information publications. Other applications of the courts include commercial GPS and altitude and heading reference systems, which provide stable heading and position even during GPS interruptions. And I've had this experience surveying the field. Another would be open architecture for high performance promising in drones processing, and utilization of standard flight test instrumentation. The pilots mainly would benefit from this in terms of safety. And now we can get into my demo of the solution. So yes, let me share that. Before you is the application itself. So clients will have access to this, and so will the contractors. They'll be able to fill in all their details, and immediately they do so, the structure pops up on the map. and they're able to see if they're externally outside, if they're in the safe area, and if they've violated any regulations. So I will be filling this form, for example, just to demonstrate. You can pick a company name, and maybe they have, per se, a crane too they want to build a part inside the airport, and they want to, let's say, maybe expand. So we can place them here. Then we'll give the crane a height of about 70 per se. And Joma is at about 1624 meters above sea level. And this is automatically calculated. So at the same time, we can include the user ID that mainly would be used to follow up on who has registered and create a personal account of them for them on the database. And this also is sufficient for the clients with the internal staff. They'll now have usernames and user IDs. This is a new submission, and we cannot put a status. It's not applicable. The contractor will take a picture of the buildings and submit their email. I'll just use a dummy phone number for now. And other documents may be needed. They'll be submitted here. We also need to provide the full names of whoever is registering and their ID number, or if it's a company, their registration number. After that, we submit the form and an email is sent to both me and the client. So here is an email, for example, for me, and this is what goes to the clients. And it informs them that the structure has been recorded, which is the crane and the company name, and the procedures have been checked against the obstruction identification surface, what you saw as a white oval. And at the same time, they're required to see the results via the app itself. So if you click this, it takes you back to the app where we were. And now they're able to visualize their data in 3D. Alongside this, they're able to see their details, for example. And from there, they can proceed to contact the authorities for other procedures that I'll show you on the phone app feature, which would be more convenient than using a desktop. They may also be wondering how we came up with the decision to have them register. So I've created a video that describes how we decide who violates the airspace and by how much. That way they understand how we come up with our solution. So once they're approved, they'll just proceed with the structure. If not, they have to carry out a reinspection. And most of the times, this is beneficial for operations within the airport that happen either weekly, daily, or periodic. So they will have to register the date of the inspection, who's the responsible department. It could be the air traffic control center, flight dispatch, engineering, technicians in the field. And what's the benefit of it? Are we doing a landing guidance system or public safety? Let's say if it's outside the airport. And also we want to ensure that if it's an urgent matter, it's resolved as soon as possible. If it's advisory to be checked, that they should do so accordingly. At the same time, the person who does the inspection will leave a rating of how the status is after they did the inspection for the next person who will inspect. Yeah, so now I'll display the phone feature, which has the same data you're seeing here. So for the phone app, let me just share that. So the clients will be able to benefit from this as they provide Are you able to hear me? All right. Let me just continue to wind up this presentation. All right, yes. So I was describing the app feature on the phone. So contractors are able to apply here onwards by clicking apply now, and they'll be able to access the KAA data port. They're able to pay for their issue. And the internal portal is for the airports authority, where they can do airfield inspections, property management, and asset and utility management. Resources are also provided here if they need to contact certain industries such as insurance for insurance claims, logistics in the commercial, and approvals by the government. At the same time, licensing and charting for our clients. They can find all that here. So yes, I believe that is it for my presentation. And yeah, I'm grateful for the team here at Esri for enabling me to showcase this product. Thank you. I would like to pass on to the next presenter. That's the team from Uganda. Yes, let me proceed.
Greetings, everyone. I think my screen is being shared. I don't know if you're seeing it. Greetings, team. This is Tim from Uganda, and thanks to the previous presenters. Behind the presentation is Ampumusa Dzaya, a graduate with a Bachelor of Arts with Education, Geography major, and is currently pursuing a postgraduate in Masters of Geographical Information and Remote Sensing at Chambogo, with a strong foundation in spatial thinking and developing advanced skills in spatial data analysis. And she's highly motivated and actively seeking opportunities to apply the GIS skills to the spatial data analysis and the mapping. Looking forward to solve the problems using the GIS and the remote sensing framework. For example, the study that I'm going to present to you, my research was on Kampala air pollution mapping, hotspots, drivers, and exposure. And my study area, I did Kampala as a whole district, whereby it has grown in urbanization, industrialization, urban migration that is leading to the high pollution indices. And it has been quoted in different writings that Kampala in Africa is the hotspot for air pollution, and air pollution is not static. If it continues and different areas will be affected, and it will not affect Kampala as a country, but it will affect the global version of the world. So my presentation was looking at the problem whereby air pollution is being an invisible health crisis with fewer measurements in the area, whereby the community cannot be able to access the data, cannot be able to visualize what is taking place in the area. So I tried to embed GIS and remote sensing skills to see how possible the community or the organization and the government can be able to access data or to identify areas that are at risk. My objectives, I had, the problem was to analyze air pollution, particulate matter 2.5 and particulate matter 10. These are micrometer organisms that are small in size, 2.5, 2, and 10, that can be inhaled by the human beings. For example, when we talk of smoke, when we talk of dust from roads or from buildings, most people may not know that they are harmful to our bodies, but that's the problem that I was trying to analyze. The specific objectives, I was examining the spatial distribution of particulate matter 2.5 and particulate matter 10, access different drivers of air pollution, and develop a risk exposure map of Kampala. The study took a data capture process whereby we had to collect data from different available sources of air pollution, from the air core, the online data that is available to be accessed by the community, then collect data for land use changes in Kampala, roads, population, and settlements. These are some of the drivers of air pollution or sources of particulate matter. We stored it in different formats and had to display it using ArcGIS online to do the modeling, the analysis, to come up with the visualization of the data and to be used by the end users, for example, the government agencies, institutions, and organizations. This is a sample of the data that was collected from EACO, the available online sources where someone can find related data of air pollution, that is particulate matter 2.5 and particulate matter 10. Let me take you through the workflow and the So from the data I collected, we had point data that was related to air pollution, and we collected it from different monitors within Kampala, whereby you're seeing the monitors available in Kampala. We have not more than 20 monitors, making the data variability less. So meaning you have to consider providing other ways that we can find data. We ran a different analysis, whereby I ran a spatial analysis of hotspot analysis to come up with areas that are producing or are being affected by the high population data. For example, if you look at Kawempe, where you see particulate matter 2.5, the different divisions of Kawempe, you see particulate matter 2.5 is 3.8, the average per year, whereby we use the data from 2025 from the data provided by the online sources or by the monitors that have been provided within Kampala. This data can help in identifying the sources, the different areas that are at a high risk or that need interventions with controlling air pollution. When you look at different areas, for example, if you consider to check Kawempe, it is showing the particulate matter, the average is high. When you come to Lake Victoria, it's a natural filter, you will see that we don't have any data of air pollution, meaning this map or this illustration will help you to identify which areas are need, which areas are to be worked on first, and which areas need to be prevented. Then we are going to see how it came on the drivers of air pollution in different areas, whereby we said we worked with load density, population density, and settlement density. Why load density? Because it is a high pollutant area when we talk of traffic density, when you talk on road construction, and population density, where you expect number of people, there are different activities taking place. Settlements, there are different activities taking place. So in the process of identifying which areas and which policies to be implemented, you have to understand what is the cause of air pollution and where is it. So after identifying where it is, you had to consider what is taking place in different areas. So that's why we had to collect data for load density, to identify where is the traffic using the density analysis. And we classified all these different sources into a high, low, moderate, and very high areas. So if we were to say in high, this is how you can see in road density in different areas, Kawempe. When you say you work on Kawempe, you will see that road density in Kawempe is not as high as population density or settlement density. So different drivers are driving different air pollutants. And when you say you talk of the low, what is low in different areas, you see load density is taking high. So meaning Kawempe, it is the source of air pollution in Kawempe is not roads or its population density, settlement density. When you talk on population, you see the population density, the high, we have different classes. That's why you find in some class, you find there is no data because the availability of the data is less to what we had classified. So you will find population density in Kawempe is high, meaning main sources of pollution in Kawempe are coming from the population within, maybe the activities that people are doing, or the different areas where people live. If we say high, you will see that settlements in Kawempe are high in this area. So meaning there is high settlements and high population that may lead to the high pollutants and production of air pollutants. From these areas, after reclassifying and overlaying different data sources, whereby we overlaid the population data map and the pollution data map, come up with an exposure map that was going to help us to know which areas to start with and which areas that need concern on air pollution control. We came up with an exposure map that was able to we were able to identify the area that is at risk, meaning if the policy are to implement different policies on controlling air pollution, or if organizations or different agencies want to tap into air pollution control, this would be the area to look at first. This was embedded or was considered with the different land cover. If you are to look at what is the percentage covering Kawempe, this area of exposure,
Hello, Desire, we can't hear you.
I had a connection and I don't know if you are still viewing my screen.
Please reshare.
So we were on the exposure map. We are looking at what activities are taking place in different areas. For example, if you identify the area in Kawempe, you will find that the built-up area is taking up 64.9%. So this map or the exposure map or the land cover or the previous maps that we have presented, they will help in the formation of different policies to be implemented in control of air pollution. If you know that there is high built-up area, you have to find ways of how you can consider on creating green areas or natural areas to filter the atmosphere. If you find the area is, for example, if we go to Nakawa, you will find that Nakawa is having patches where the air pollution is moderate and then unhealthy, not too high healthy. The reasons why the areas that are provided are showing high and moderate, when you check in the previous exposure map, as presented. The hotspot map, on my indicators, I was showing World Health Organization recommends an annual mean of 5 for particulate matter 2.5 and an annual mean of 15 for particulate matter 10. And when the data we used, we found out that Kampala as a whole district or as a whole area, it didn't have where it has been that Kampala is a safe zone for human health. That's why you find in my presentation, you will find I have moderate, I have health, there is nowhere where I have this area is favorable for people to live in or is related in air pollution. So this data will be used by different people to identify areas that need to be worked on first, that need to be, and different policies will be recommended for different divisions or different areas regarding the control of air pollution. That's why we had to come up with this. Go back to my app map, my story maps. From the whole study, this can be the presentation or the whole study that we did and how it can be presented and read by different organizations. And we created different maps showing different products that can be displayed to the communities or can be displayed to different organizations to identify or to give reasons why area A or area B should be considered, or why different measures should be input for different areas. In our recommendation part, we identified different hotspots, and this data will help in visualizing different hotspots of air pollution. It will help in planning and control measures of different areas for different air pollution data. We also looked at the data that we provided or the maps we provided will be used to support environmental programs. For example, in identifying which policy is favorable for different areas where we have high density of roads, the policies recommended there will not be the same policies recommended for where we have high population or high settlements. And it was also helped in visualizing data that most of us wouldn't have visualized, because as we listen or as they tell us that there is population, you don't see it. Neither if you are not affected or if you have not gone to the hospital, you won't feel it or you won't say that there is air pollution, like how someone would provide you with dirty water and you say, no, this is dirty water. But for air pollution, we all have to breathe, and so we all have to, our health has to be worked on. And this is the data that will help us to know if there is air pollution control. It can also be used in further research for different research groups, and the recommendations that we had from our presentation, air quality monitoring networks and emission inventories should be expanded. For example, the data that was provided, we had different monitors for the whole Kampala. That will not give you the enough data or the real data that you need. And the city should implement cycling networks, pedestrianized streets, and redesign urban spaces. For example, if you had considered the Kawempe division where we found high pollution, there should be a more designed urban space for natural spaces that can help in filtering the atmosphere. Then we look at the network and the load density. We can have cycling networks, we can have pedestrian, than more of, because Kampala is more of depending on individual cars and old version cars that lead in the production of these pollutants. Then laws and policies can be implemented and fraud by individuals for pollution control. And also from the data, there is need for the policymakers or the organizations that need to control the air pollution, or the communities should have to know or to learn about it. So there is need for community involvement and teaching about air pollution. And to wind it all up, I want to appreciate all the team that we have worked with, the previous presenters. Thank you so much. The Kenyan group, the Tanzanian group, and the Ugandan team at large. And for the supervisors, I would like to appreciate Mr. Jonathan from the East African for the opportunity given, because it has opened my skills and it has opened my network. Thank you so much. Thank you so much, Mr. Jackson and Mr. Dennis, for the guidance and your time during the whole process and how our data was going to work and be presented. And for the experience given by the East African for the interns, thank you so much. And we appreciate for the work you are doing for the community. I can stop from here and allow the next presenter present their work.
Yes, thank you, my colleague Desire. I would like to say a good afternoon to everyone. Yes, let me hope you're viewing screen, and you can unmute and inform me if you're viewing. Yes. I'm called Open Road Samuel, and a graduate from Makerere University and a GIS intern from at Esri. And Esri has given me a very wonderful opportunity to have an internship with them. I am a geospatial scientist with experience in climate and environment. So with the opportunity that Israel has given, I wish to turn this knowledge into spatial mapping, and hereby I come with the topic climate impacts on food security, and that is Acholi's food. As you can see, the feeding food basket as my title. The introduction, my West Acholi has been is the food basket of Acholi tribe and northern Uganda as well. And this is the way the landscape and the settlement system is. It's still most of the areas are still rural, and as you can see the kind of settlements they are in, and with them depending so much on agriculture, and the agriculture is also dependent on climate. So with the climate that is affected, that is increasing and erratic, it has really created a big challenge for them, and they are now getting a double standard impact from both climate change and failing to access food. And then my problem comes in from the increasing unpredictable climate patterns that has really affected people's gardens, and the food that has been harvested is really decreasing. So that is the major problem that is happening in my area that has made me to come up with this topic. So there has been a shifting rainfall mean in the from the period that I've taken note in, that is from 1999 to 2024. There has been really a shift in the mean, as you can see the differences in the color variations, whereby on my left is the map from 1990, is the mean map, annual rainfall map from 1999 to 2023, and on my right you can see from 2020 to 2024. I used the mean of I used a range of 5 years to get the mean. And then for temperature as well, there has been an increase in temperature, and this is from the data collected from CHAPS, where I had to get the average mean and the average temperature from 1999 to 2003 and from 2020 to 2024. And my objective of this study is mainly to analyze the temporal rainfall and temperature variability from 1999 to 2024, and to assess the physical vulnerability of West Acholi based on soil suitability, and then to quantify the spatial intersection of high human density. So with this is my study area. As you can see, you can zoom it in, like maybe when you access this story, really like to see how West actually is. You can zoom it in and you'll be able to see all the small and tiny features that are within. And so I'm going to take you to how I did my work. I got that rainfall data, soil characteristics data, and temperature data was analyzed using ArcGIS Pro, and it was exported online in the portal. And now the people will be able to visualize it through a dashboard and a story map. So using the data that was downloaded from CHAPS, that is the rainfall data, that it's a multidimensional data that was downloaded, and it was downloaded and analyzed and turned into polygon, where we got the trend, the Mankendal trend analysis. This is the significant map that shows the variation of rainfall, because rainfall has been increased. There has been an increase in some areas with 6.6 millimeters per year, and while other areas we are getting a decrease of 0.3 millimeters per year. And the brown areas are the areas that were really getting very significant decrease, and while the areas in green are the areas that were experiencing an increase of 6.6 millimeters per year. So there has also been, with that same method, I also had to do it for temperature that was downloaded from the T2M from ERA 5, and it was run in the same way, where we're getting running the Kendall analysis to get the trend of how it is really increasing from 1 year to another, 1 year to another. And the mean was run, and that is where we had to get that there is a general increase in temperature. It has no negatives like the one for the rainfall, but this one now explains that this one now brings it out that there is a steady increase from 0.032 degrees Celsius, while other areas, the most risky areas, are experiencing temperatures of 0.04 degrees Celsius. So when you're looking at climate, I had to look at both rainfall and temperature, whereby the two were aggregated to get the climate stress index, such that we can be able to visualize which places are affected by all the two parameters. And then I used the weighted outlet tool to make the analysis. So you can see the areas in green are the ones that are waiting and at least stable, while the ones in light green are stable. And you can see the warning zones and the extreme vulnerable places. You see them in red because I classified all this data in 5 classes. So when you see the red, that means class 5 means there is a lot of vulnerability in that region, while class 1 explains that the region is very, very favorable, and that is how the variation goes. Then going to my second objective, you can note when all these two parameters combine, that is rainfall and temperature, they all affect what is used for growing crops, and that is soils. Because soil is the most important thing considered when you're planning to start up or open up a farm that will deal in production. You always have to look at the soil, so we can see the soil vulnerability. And as you can see this with regards to its sensitivity, you can see the variation in colors, whereby you can be able to spot up the places that are critical hotspots, and you can also be able to see the places that are low resilient. And as you can see, the places that are really resilient are very few. Just a very small place that I think it's always not used for farming. And this variation shows that the climate is not just coming like a uniform wave. It is not uniform, as you can see the areas, and you might be experiencing a certain climate change here, and it's different from the ones of your neighboring areas. So this analysis was got from the soil data that was downloaded, checking the sand soils and the clay soils to see the retention and their ability, and not forget the soil density was combined and classified to bring out this map that someone can be able to visualize and spot out which areas would be good for his or her farm, or which area are people so vulnerable. Or you can check on the vulnerability of your farm. And that data was from the population data. I mean from from the soils data, it was still integrated with climate stress to assess more vulnerability. Because when climate combines with soils, the vulnerability becomes more severe. You cannot look at only climate stress, but you can also look at the soils as well. So this analysis was meant for people to visualize areas where it was meant for people to visualize the areas that are being affected by both climate stress, and also they are not, and also they are where they are located, the soils are not good enough for farming. And you can see the very, very red zone, that one, there is critical vulnerability, meaning those people are suffering from all the three combined parameters, and they really need to be helped. Maybe if you're an organization that you're looking forward to helping vulnerability when it comes to production, food security, and agriculture, or maybe if you are a businessman that you really want to supply your food, you can see this. You can see the areas that are really so vulnerable, and maybe you can get your market from there. Then relating it to the human, there is population data, because population comes in a two-sided way, whereby the areas that are densely populated, the demand for food is always high, and this is just to help people who are going to visualize this story map, not to only, because they may think and say, we are going to supply food, but we are not aware of the population, the people I'm planning to help to build resilience, and there is no population data. So this is the population data, and as you can see, the areas that are densely populated, that means there is critical human exposure to both climate and food security. So in conclusion, there is need for data driven analysis in order to build resilience, and to help West Acholi that has really declined in its food production rate. So because currently I know there are a lot of organizations that are looking to help, and there are also a lot of people who might be willing, who might have land, might be willing to do some crop production in that place. So I think this story map can be helpful to you who is going to engage in that, or if maybe you're a member of that place and you would really like to know the agriculture of your area, or if you're a neighboring area and you would also like to know how your area is doing via climate change and food security, you can relate to this story map. And then not only the story map, there is also a dashboard for maybe the people who might have only visualizing the maps and seeing the figures. So this is my dashboard that when you access it, you can be able to click and visualize. On the this front part, there is that is the rainfall area in hectares, and you can see the area that has been covered by a specific by a specific parameter or a specific challenge that was in the story map. Like if you see where there is high rainfall, you can really see this is the area of high rain, the area that high rainfall has occupied. While also in the dashboard, yeah, I think it has now updated. Yeah, the users will be able to to click, because as you see from the side screen, this is the annual mean rainfall of 1999 to 2000 to 2003. Maybe those who believe they want to go scientifically and maybe make an and maybe have an overview of it, yeah, you can come and click here on the moderate, and it brings for you the shape. As you can zoom and see the shape, and you can see the area occupied by it in hectares. So that is for 1999 to 2003. And as you want to compare, you can come and compare with the one of 1999, I mean of 2020 to 2024, whereby you can also come in and zoom. You can come in and click. Then maybe you want to see where there is severe risk in temperature. Yeah, it also comes in, and you'll be able to view it. So in conclusion, I would really love to extend my my appreciations to Esri Uganda, to Mr. Jonathan, and to Joyce, and all the interns who were there, and they were really of good help, and we shared a lot. And also my supervisors, Edwin and Dennis, I really appreciate you so much for the help and the guidance. So I would like to welcome the next person to present.
Thank you, Tim. Thank you, Samuel. You are actually the last presenter, and that marks the end of this internship presentation. I believe most of the questions that were on the chat have been answered. Unless we have a burning one, we can give room for anyone who has a burning question to any of the presenters to ask at this point. You can unmute your mic and ask, and your question will be addressed. If you have any queries, if you're interested in any of these solutions, you can always reach us through our sales email, sales@esriye.com, for any inquiries on the solutions presented here. We can have that sent through our email and we'll be able to reach out and address.